Okay, so today we are starting a new portion in the graphing world, and we are going to call this portion. So, on your paper that you've given, please write the assignment number, put your name. Many of you have gotten in the bad habit of not putting your name on assignments. And at the very top of this page, we're going to take some notes about slope. So, first thing you need to know about slope, I'm sure you've heard of it. And I'm sure what mostly comes to your head is rise over run. The definition of slope is, or what we need to know is this is a proportional relationship that measures, so that measures the steepness of a line. And as you can see down below, steepness of a line. And as you can see down below, there's lots of lines on this page. And if you look on the back, there's lots of lines on the back, and you're going to be getting the opportunity to graph lines like you did earlier this week. Oh, I should have put steepness of a line, not lines. Okay, I did it again. Line. Okay, so we also want to know that slope is represented by rise over run, and you've probably heard this. When we talk about rise, we're talking about the number of units we have to rise up and the number of units we have to run over to get to our next point, and we'll get down here in a second. We also want to note that slope is represented by the letter M. So, you know how area is represented by A and perimeter is represented by P? Well, the word slope is going to be represented by the letter M. I always get the question, what does M mean? Why didn't they use S? Because slope starts with an S. Well, I just found out through a little research on my good friend Google that M stands for mons, which is mountain in Latin. So many people believe that the M is represented by that because they wanted to think, okay, steepness of a line, these kind of look like mountains, right? If you went up like that, oh, there's your mountaintop, your snowy mountaintop. And since we know Latin is the base of our language, this M for mons, or you can think of mountain, that's what M represents. So, in case you were wondering. All right, now let's look at these four graphs. The first four graphs. There are four different kinds of graphs that you'll see. They're kind of like families. So here's the different kinds of slope represented by these four graphs. And I would draw a line down here because we're just really going to be talking about these four. So this here is a positive slope. So underneath it, we're going to write positive. How we know it's positive, well, a couple of reasons. When we move from left to right, we notice that our line is going up, right? Our x values are getting more. Remember, our x values are negative over here and they're positive over here. So our x values are getting greater as we move from left to right. Just like reading, always think of it like left to right. Our x value is going up or down. It's going up. If we were driving a car, this would be going uphill. So think of that. This is positive. This one then would be a negative graph. Negative graph. So think of a car going downhill. You're going down, down, negative. And again, moving from left to right, are the numbers getting smaller? Are we going down or are we going up? We are going down. So this is a negative graph. Now this graph here is right here. You can't really see it. But it is right here. And this graph that's flat horizontal line has no slope. So we're going to write no slope. Or we're going to write 0, slope of 0. So I'm going to put that in parentheses. Now this would be if the road was perfectly flat and you were in the car. That's no slope, like maybe out in the desert or something like that. So again, this is a car going uphill for a positive slope, downhill for a negative slope, and this is just a car going along, maybe, downtown Martinez on Main Street, very flat. Now this one here is this line, and it's a straight up and down vertical line, and this is an undefined slope. Now think of this as undefined for now, because you can't drive a car on this road, right? You'd fall. This is like a cliff. You can't drive a car up a cliff, you can't drive a car down a cliff, you'd crash. So this is an undefined slope, and we'll go over why that is in a little minute. So now, what are the slopes of these lines? Well, remember we said slope is rise over run. So you'll see dots on all the graphs down below, and with the exception of this one, but that's because we're going to add them. So you're going to start at one dot, the lower dot, this one right here, and you're going to rise over run. How many units do we rise and how many units do we run in order to get to the next dot on the graph? So I'm going to rise up 1 unit. I'm going to run over 2 units, and since it's a positive, we write 1 over 2. So rise over run. Rise 1, run 2. And this is a positive graph, so this is a positive 1/2 slope. Oh, actually, how we're going to write this is m equals 1/2. Remember, m represents slope if you look back up here. So over here, remember this is a negative graph, but we start at our lowest point. We're going to rise, how many? 1, 2, and we're going to run 1, 2. Well, now notice this time when we run, we go in the negative direction. Remember, x is negative over here, positive over here. So we rise 2, we run -2. So this is a -2 over 2, or -1. So m equals -2 over 2, or -1, because remember 2 over 2 is 1. So that's our answer. Now this one here with no slope, we can just write the slope is 0. It's a flat line. No steepness, 0. This one here, undefined, all vertical lines are undefined. And that is mainly because if we did rise over run, our denominator would be 0, and let's say it's 1 over 0. You can't have 0 as a denominator, so this is like impossible. We want to do sad face here. Not going to happen. So this is an undefined slope. Another thing I want to point out is that in our definition of slope at the top, we wrote that it is a proportional relationship. So if we look here, this says proportional relationship that measures the steepness of a line. We might be thinking, what the heck is proportional? So what proportional means is this is the same for each step of this graph. Now watch, we use this one here. Now in a different color, I'm going to rise 1, go over to the right 2, because I'm positive. Isn't that the same? This is proportional, meaning it's the same little triangle here as the triangle here. And look, if I started down here, on this point here, I would rise up 1, go over 2. And there's my next point. I would rise up 1, and go over 2. Proportional just means that this pattern repeats itself along this entire line, and it will work for every single line we do today. Here we have 1 over 1, so we can say, oh, this one here rises up 2 over 2, up 2 over 2. But even something more interesting about that is that this could, since our slope is 1, this could rise up 1 over 1, up 1 over 1, 1 over 1, up 1 over 1, all the way up. This pattern just keeps going. And this is proportional because they're like fractions, right? 2 over 2 is like 1, or excuse me, -2 over 2 is like -1. So either way you look at this, it is proportional. So I'm going to do these first 3 with you. And what we want you to do is first tell us if the slope is positive or negative. So this first one here is a negative. And then we're going to write m equals what? Well, I'm going to start at my lower point, remember, and I'm going to rise up. So 1, 2, 3, 4, 5. So I'm rising up 5, and I go over 1, 2, 3, 4. So since I'm going over in the negative direction, because remember this is negative, this is positive, this is negative 5 because I rose 5 over 4. So I rose 5, I run 4. All right, let's try this one. This one's also a negative graph. If you see, if you move from right to left, you're going, or excuse me, from left to right, you're going in the downward you're going in the downward direction. So this is a negative graph. You start at the lower point, you rise 1, 2, 3, 4. So negative 4 over, how much do you run? 1, 2. So m equals negative 4 over 2. Well, what is negative 4 divided by 2? Negative 4 divided by 2 is negative 2. So that is what m equals. Now this one here, we have a positive graph, and you'll notice that this graph does not have points on it. But we're going to put some points on it. If we see, we want to know right exactly where the line meets the intersection of the two boxes. So one of them is right there, one of them is right there. So you're going to rise 1, 2, 3, 4, 5, and you're going to run 1, 2. So we put 5 over 2. We know this is a positive graph, so we don't need a negative sign there. We're going to write that this is positive. We're going to write m equals 5 over 2. So for each one of these graphs, you need to write if it's positive or negative, and then you need to tell me what m equals, what the slope equals. You also need to have these triangles written on there. So for this one, we have a triangle. For this one, we have a triangle. We also could have put another triangle down here, right? Because our proportional relationship, these triangles are even. It's 2 by 4, 2 by 4. Over here, we can't really add another triangle, but notice how we have triangles up here too. So triangles, positive or negative, and what m equals. Go ahead and complete the rest of the worksheet.